This is chapter 17, question 105. Now, this is a question that combines a lot of chapters together. So, it is very common in Cambridge A levels exam that they want you to know how to relate the concept, okay, in a few chapters together. Now, they are talking about concentrated sulfuric acid here. Concentrated sulfuric acid actually is a very useful chemical. It can function as a lot of roles in many different reactions. In this case, they only want to talk about um, concentrated sulfuric acid as strong acid and also oxidizing agent. Okay, and how this concentrated sulfuric acid react in this way, okay, and in which reaction. Now, if we have concentrated sulfuric acid with ethanol, it will actually become a dehydration reaction. Okay, so if you react ethanol with concentrated sulfuric acid, ethanol will undergo dehydration reaction. So in this case, actually, concentrated sulfuric acid is an acid and also a dehydrating agent. Okay. Now with magnesium carbonate is quite straightforward. Carbonate with acid. Okay. Then the acid will behave as an acid. But there's no change in all the oxidation numbers. So concentrated sulfuric acid is not an oxidizing agent in the reaction with magnesium carbonate. Now with propane nitrile, concentrated sulfuric acid, the H plus ions and the water in the acid could be um, could make propane nitrile to undergo oxidation. Sorry, hydrolysis. Okay, but concentrated sulfuric acid, um, it doesn't have a lot of water in it, so it won't actually react with propane nitrile. Then the last one, we have sodium bromide. Now this is from um, chapter 12, group 17, halogen. Now, when sodium bromide reacts with concentrated sulfuric acid, okay, what will happen is there will be first and second step. Now, first step will be NABR and H2SO4. Okay, you will get HBr. Okay, and then Na2SO4, sodium sulfate. Okay, of course, this equation is not balanced. If we want to balance the equation, it will be like this. Now, this is step number one. Now, in step number one, you can see that sulfuric acid lost the H plus, right? It became the proton donor. So, in this step, it is actually a strong acid. Okay, it actually behaves as an acid. Now, HBr can be further oxidized. It can be further oxidized to SO2. Okay, then bromine. Okay, water. Now let's try to balance the equation. I should have 2HBr, 2H2O. Okay, this is the second step. Now, second step, look, HBr, the Br in HBr has a -1 oxidation state. Okay, but in Br2, okay, it became 0. So oxidation occur. Now, since HBr is the one that undergoes oxidation, it is a reducing agent. That means H2SO4 is actually the oxidizing agent. Okay, therefore, concentrated sulfuric acid can behave both as a strong acid and as an oxidizing agent, okay, in the reaction with sodium bromide. So the answer to this question is D.